DFS basically just two things. At every step, you look locally at adjacent nooks. 2, you move to one of the adjacent nooks and store the other nooks, and that's it. So suppose we start with this figure, ignore all the number on the edge, so ignore this. So let's say we start with 0. Repeat what I do here, 1 and 2. Please don't do DFS on this whole graph. Doing DFS on this whole graph is wrong because that means you have global information, you see the whole graph. Computer don't see the whole graph. Computer only see locally, so you should do on a subgraph. So 0 only see the subgraph of 1 and 7. So you have choice, you can either move to 1 or you can move to 7. And let's say we follow the order that we move to the small number, so we go to 1. So we go to 1, but 7 haven't been visited, so we put 7 in a box. So this box will be carried over when we move, so we put the 7 in a box. What's next? Repeat what we do here on nook 1. So again, we draw locally the graph that connecting 1. So we see 1 can go to 2 and 7. And since 7 already stored in this box, so we cannot go to 7, we ignore this. That means in this case, we only have one choice, so we go to 2. So we go to 2. And if we go to 2, we have to carry this box to 2. So we carry this box to 2. That is 7. Okay. What's next? We repeat the whole 1, 2 thing here. So at 2, what we can see? So 1, 2, 3. Okay. So let's say we go to 3. We follow the order. So in this case, we will move to 3. We will move to 3. And then carry the box here. And these two guys haven't been visited. So we will put them in this box. So that means in the end, at nook 3, we will have 7. And then we put the nooks, unvisited nook, that is 5 and 8, to this box. Then now we're at 3. So what's next? 3, what we see? 4 and 5. Look at the box. 5 is inside the box. So we don't go to 5. We go to 4. That means we have no choice. We can only go to 4. So we will go to 4 and carry the whole box. Okay. What's next? At 4, we can see what? 5. 5 is already in the box, so we cannot go to 5. So now in this case, we reach the end for this particular path. So that means what we do? We go to the box. We look above the box and see the number that we see. We see 8, so we will go to 8. So we will go to 8. So we go to 8. And then because we go to 8, so we pop out this 8 and we get 5 and 7. So we get 5 and 7 here. So what's next? At 8, what we see? To 6 and 7. So again, 7 has been in the box, so we cannot go to 7. That means we only have one choice. We go to 6. And then we carry this box to 6. So we carry this box to 6. So we get 5, 7 here, and we move to here. So now what's next? At 6, we can go to 5 and 7. Since both 5 and 7 appear in this box, that means we reach the end. So we now look at the box from the top, which is 5. So we will go to 5. And then we bring the box, so that means we have 7 here. So lastly, at 5 here, I repeat, technically we are connected to 6, 2, 3, 4. That means we are connected to 6, 2, 3, 4. But all of them have been visited. So that means we reach the dead end. So we look at the top of the box. We see 7. So we go to 7. Okay, so that's it. So that's the whole DFS. Now, once we get the whole pathing, we can actually draw the corresponding tree. So that means what? The DFS tree. So we start with 0, then we go to 1, then we go to 2. Let me draw letter. Then we go to 2, and then we go to 3, and then we go to 4, and then we go to 8, and then we go to 6 and 5 and 7. So 6 and 5 and 7. Okay. So this looks like a change, but if you look at the graph, actually you see that actually 7 is connected to 0. So basically you can put the 7 here. Okay, let's say I put the 7 here. And furthermore, if you look at this thing and compare the graph, for example, you see that 8, 6, 5 is also under 2. So this chunk of thing can be moved under 2. So basically, you can draw a tree like this. And if you work on DFS on a tree, you know that for DFS on a tree, basically it's going down, and then turn, and then turn. Well, this gives you the same result as the DFS here.